Gold Standard GAMSAT is back again. So it's been 6 years since ACER published their last new practice materials, which was GAMSAT Practice Test 2. And it's been 3 years since we put out a video for the work solutions for ACER's practice questions. So we put out over 100, I still can't believe it, I'm hesitating to say it, videos on YouTube going through all the work solutions of the Section 3 practice questions, so over 330. And here comes another 110 work solutions to their practice questions. So it's been a couple of months since ACER came out with the pink booklet, also called GAMSAT Practice Test 3, which is their fifth of their practice materials or ebooks. And I happen to be here in Melbourne between delivering some GAMSAT practice courses, using some free time to connect with you once again. And because we do listen to some opinions from different corners, and I know that some people would rather not have commentary to the work solutions. They just want to get right to it. And for this exam only, and for Section 3 only, we have also put together the written work solutions without commentary, so just getting right to the meat of the issue, and we put that on our website. It's free, so you can get a free account and go to gamsat-prep.com and log in, and then click on tests in the top menu and scroll down to find the link to the ACER GAMSAT Practice Test 3 Section 3 worked solutions as written answers. So that way I can continue to give commentary to most people who would find that having background information on the types of questions, reasoning strategies helpful. Okay, so what else? I would also say that if you do have alternative solutions to any of the practice questions, post your solutions in YouTube or in our forum, gamsatprep.com/forum. Share that. But of course, you're not going to, don't hate another presentation of a solution just because it's not the way you would do it. If you have another way, just share that. I'm definitely not even, as part of my objective, to show every single possible way to solve a problem. I'm just showing you what is, in my opinion, an efficient way, and yes, from my point of view and from my perspective and from my experience. So that's how we're doing it. So the other thing that I would say is that if you do enjoy some of our books, our videos, our courses, our any of the content that we come up with, then it would be really appreciated if you liked it somewhere or if you commented somewhere. We have stuff at co-op bookshops, at Amazon. We have materials, of course, YouTube, Facebook, online. And so, if you like it, it's very much appreciated. And if you're not the kind of person who likes things, I understand that too. But, in this era where, there's people going around making fake accounts and making fake posts, it's nice to have some real people say something positive, especially in response to efforts to try to help them have some useful and helpful resources. So, but if not, you can always pay it forward. You can help an old lady cross the street or do some nice event in life, and then the world will just be a better place altogether anyway. Okay, so now let's take a look at, we've got 110 multiple choice questions to get through. I have to comment about the way ACER started this. The first in many years, and I have to say in the last few years, ACER has been trolled by many students who have repeated GAMSAT and have been going online and really complaining that ACER didn't have anything up to date and that their other practice materials weren't really reflective of some of the changes that have been occurring on the real exam and so on. So there's been a lot of complaints about this. You can go to Paging Doctor, or which is a great website. Particularly focused in Australia. There's also a student doctor website in the UK as well that is very helpful, and boards.ie in Ireland. But in Paging Doctor, there's been just a plethora of complaints about this, and this is juicy because ACER starts their new booklet with, of all things, the circulatory system, because this is how they started their first booklet ever, which was some 15 years ago, which is called GAMSAT Practice Questions, which is used to be called the red booklet, but it's been looking a little bit orange lately. So anyway, everyone should basically own all of ACER's practice materials, including the oldest one, which is the first one, GAMSAT Practice Questions. And yes, there are some pretty easy questions in there, but there's a lot of questions in there that are still GAMSAT level. And I think ACER was underlining this point by choosing, of all things, circulation for the very first one, which is from their very first material, their very first unit, and also by having a second unit. Later on, we will be discussing around question 31 or something. In this pink booklet, there is yet another unit on the circulatory system. This is really astounding, and this really underlines how useful all of ACER's materials are, to one degree or another. Okay, that's legitimate, but at least all their materials are very useful and will help you improve your chances of doing well on the real exam by going through lots of practice. Try to keep in mind the expression that's being used in medical schools, as well as by ACER, and that's problem-based learning, a very important part of your preparation for the exam. Okay, so looking at questions 1 to 4, there's a mention of the ventricles are relaxed in ventricular diastole. And then in the second paragraph, what I would be underlining is that the stethoscope detects 2 sets of sounds. Of course, this is normal, during normal. And the first results, virtually simultaneous snapping shut of the mitral and tricuspid valves. And then secondly, the not quite simultaneous pulmonary valve and aortic valve. So I think those things are worthy of being underlined. Then you sort of look at the figure 1, but you don't really have to analyze it too much. You should have a basic background knowledge of circulation, and then you would really go to the questions to help you direct your understanding of the figure diagram. And so the first question is about which valves are open. Okay, so first I'm going to present the new gold standard GAMSAT book. So this is the new book that we have that's had a lot of extra material added, and in particular I do want to make sure that you understand why I had some words written over there before, and it's because of this. So here it's color-coded, and here are the most important sections that you need to know in terms of SUM knowledge. It's about the eukaryotic cell, or cell biology, the circulatory system, which is, absolutely essential, and genetics. So, in other words, it's not that every chapter in biology is the same importance. It's not true. In fact, these 3 are by far and away the most important for the exam. I'll also just mention that if you do have this book, please don't skip the introduction. I know that many people like to skip introductions because they don't find that it's pertinent or helpful, but this is different, because in this introduction there's a lot of GAMSAT. There's GAMSAT graph analysis, that there are flow charts, and it really gets you to start thinking about the way you have to prepare for this particular exam. So I would say that please don't skip the introduction. Okay, now let's get down to this particular episode. So now I'm just going to quickly review for you. First of all, I should get the permission from the author to be able to use this in the video. Author permission granted. Okay, so I guess I can use it. So, okay, here we go. So you can keep your exam, your ebook or printout or electronic access to your exam right nearby so that you're comparing the figure 1 that ACER has with the one that you're looking at from the gold standard book. Of course, I can't show you ACER's because I did not get ACER's permission to show the diagram, and I'm quite sure that they would not give that permission. So, okay, so let's take a look at the blood that's returning to the heart. So first of all, the blood returns to the heart through big veins into the right atrium. And so this is deoxygenated blood, and it's shown by the color blue as just to represent it, to make it easy. Of course, no blood in your body is blue, not even in your arms, not even the superficial veins, but it's optical illusions. But nonetheless, it's easier to follow when we look at the deoxygenated blood as being blue. So you see that's coming into the right atrium. And just to orient you again, when you talk about left and right for the body, it's when you're thinking of a patient facing you. And so if this was a patient facing you, this would be the right side of the patient, and that's why this is the right atrium and right ventricle, and this would be the left side of the patient. Of course, it's your right, but the left of the patient. So in the upper part of the heart, you have the atria, the right atrium and the left atrium, and the lower part of the heart, you have the ventricles, right ventricle, left ventricle. Deoxygenated blood coming into the right atrium and then going through into the right ventricle, pumped through the pulmonary artery. Okay, so that's deoxygenated blood. So that's why you can never say that arteries always carry oxygenated blood. You can't say that because here we have the pulmonary artery carrying deoxygenated blood. But what you can say is that arteries carry blood away. So arteries carry blood away from the heart. So here we have the pulmonary artery going away from the heart, and or here we have the aorta, which is the main artery leaving the heart, going into systemic circulation, the body circulation. Okay, so we just went into the right ventricle, pumped blood into the pulmonary artery, deoxygenated, to get the blood oxygenated at the level of the capillary. This is magnificent. So here we have this heart muscle, so strong and pumping blood throughout the entire body. In fact, it's a double muscle. It's a double pump, pumping blood into the lungs and to the body system. And all of that in order to bring blood into juxtaposition with air in the lung. So the blood could be as close as possible to air in the lung, and then comes the second law of thermodynamics. And that's how we breathe. That's how we bring oxygen into our blood, because things like to go from high concentration to low concentration. Simple diffusion, which is a consequence of the desire for entropy. Things don't want to stay organized and concentrated. They want to move and spread around. And so we create carbon dioxide as a waste product for respiration. And so we accumulate carbon dioxide in our system, and then we can get rid of it just through simple diffusion in the lung, because air has lower concentration of carbon dioxide than our blood does. And so here we have the simple diffusion of carbon dioxide out and simple diffusion of oxygen into the capillaries, and then oxygenating the blood in the pulmonary vein that returns to the left atrium. And so through the left atrium into the left ventricle, and then blood is pumped to the body systems. And so our circulatory system is both in series and in parallel. We'll talk about that later when we go to question 31, but that unit. But you can see the series part. It's one thing after another, that series. And it's just like when you think about electricity and resistors and series, because ACER can definitely have a question which they want you to be able to transpose our circulatory system to physics circuits. And so it's important to see that part of our system is in series, one thing after another. And then part of our system is in parallel, and this is what this is sort of symbolizing here, sort of in parallel, because when you go to the body tissues, you have some blood vessels that will be going to the liver, some to the spleen, some to the bowel or the brain, and so there's a part of our system that functions in parallel. But we will look at that closer later. But right now, the thing that is very useful to look at are the valves. So right now, look at how we have the blood coming into the right atrium and then going into the right ventricle. Do you see the tricuspid valve here, TV, the tricuspid valve? Do you see how the leaflets of the valve are pointing into the ventricle? So now you can imagine that because the leaflets are pointing in this way, blood can flow easily when pumped from the right atrium into the ventricle. The blood could flow through the valve, but when the right ventricle is going to contract and pump, those leaflets that are pointing down into the ventricle will flap closed. So these leaflets will flap closed, and therefore blood is ejected through this valve. Can you see that? The valve. And then it will go. See, if the ventricle relaxes here, if the ventricle relaxes and blood is being pumped here, then you can see how the blood in this column here will push on this valve and close it. And so for temporarily, this valve will be closed. Okay, so now let's look over at the oxygenated blood that is now coming back to the heart. So here it's gone through the lung. Here we have oxygenated blood coming back through the heart into the left atrium. And now coming through the mitral valve into the ventricle, and then once the left ventricle pumps blood through the valve that's here, you can see that the ventricular valve, the mitral valve, is going to shut, just because the leaflets again are pointing into the ventricle. So then when the ventricle contracts, that valve will shut so that blood can eject into the aorta. So okay, and the last thing to mention is just that from the labeling that ACER used, is that you can see that right here, this is going to be the pulmonary valve because it's moving blood into pulmonary circulation. It's part of the pulmonary artery here. And over here we have the aortic valve, and this is leading blood into the aorta and therefore the systemic circulation to the body systems, bowel, brain, arms, etc. So we have now looked at all of the different labeling for the graph. So looking at the first question, which of the four valves are open during ventricular systole, during the contraction? And so, of course, we're going to have the contraction of the ventricles, and so we need to have the pulmonary valve open, and we need to have the aortic valve open as blood is leaving the heart because the ventricle is contracting. And so closed would be the tricuspid valve and the mitral valve under normal conditions. And so the answer to question 1 is B. And then for question 2, which vessels carry oxygenated blood? It's too bad that the exam wasn't in color, and then you can just point to the aorta and to the pulmonary vein. Okay, that aside, when you look at the labeling that ACER has, you can see that Q is indeed the aorta, and the reason you know that is because you can see an arrow in figure 1, their diagram, that is pointing from the left ventricle, moving upwards, pointing towards the area which we would see as Q. So then that has to be the aorta. And then for R, we can see that R has an arrow that is pointing, returning blood to the heart. And so this is blood that is returning to the left atrium, as we can see, according to ACER's diagram, and the blood coming to the left atrium, of course, that is the pulmonary vein that's bringing back oxygenated blood that will go through the aorta. So it's all in this one cycle from the pulmonary circulation, oxygenated blood, all the way to the body system. And so that is the area that ACER is referring to. So that's Q and R, and therefore the answer for number 2 is indeed D. Then when we look to ACER's next questions, we see that they're presenting a significant amount of information. I would not be thinking during the exam, I need to read every single line and understand every line. I would either just glance at the questions first to get some direction as to what I should be looking for. Because once you which I think is the best way, but otherwise you can just glance at the content presented to you and then go to the questions. But you have to try both and see what works best for you. So if you just glance at questions 3 and 4, then you have an idea that for one, they're asking about aortic regurgitation. So I'm going to be focused on aortic regurgitation when reading content, and I'm not going to spend all my time thinking about aortic stenosis or pulmonary regurgitation, because that's how you waste time trying to complete the exam, because you're always trying to focus on everything when everything is not necessary in order to solve the problem. So that's one issue. Question 4, on the other hand, talks about what the meaning of the vertical lines are. So that means that's another issue that I'm going to be looking at. So it's not that I'm going to look at all the answer choices for question 4. I'm just going to look at the question stem, the beginning of the question, and I'm going to sort of glance at whatever is available. This technique can be used for section 1 or section 3, and it will save time. But you have to try different exams using your technique and using a new technique and see what works better for you. Okay, so in going back to the content after having briefly looked at that, then I would notice in the third dot, it says the striped rectangle represents. Okay, that I would just really underline that or circle it or put an asterisk, because this is specifically referring to one of the questions, talking about the striped rectangle sounds of the aortic valve, and I know that I'm looking for aortic regurgitation. And then below that it says less pronounced sounds of lower pitch are represented by thin vertical lines. Okay, now this is again linking this content with question number 4. And then the height, and then talks about the aortic valves closed and the pulmonary valve. Okay, so now I'm really gearing up towards this, and I have in my mind that aortic regurgitation is what I'm looking for. So I look at aortic regurgitation in the table, and it says aortic valve does not fully close. If it doesn't fully close, then with all the different things that the passage has said, this indicates to me that I'm not expecting it to reveal a sound. And I know that aortic valve is striped, and so I'm not expecting to see that striped sound when I find my aortic regurgitation. So already I have in mind that the answer for 3 is probably Roman numeral 2. Roman numeral 2 is the only one that doesn't have the aortic valve. And I've already been told right at this stage that the aortic valve did not fully close. So I'm not expecting a sound from something that is not fully closed. So I'm thinking in advance that Roman numeral 2 is likely the answer to 3. Then I have a look at the different ones, and I would probably point to the gray rectangle, and and write pulmonary valve, and to the striped rectangle and put aortic valve, just to make sure that I don't confuse the two. And then when looking at the Roman numeral 2, again, not only is aortic valve not showing, but then I see that there's sound showing across diastole. So during the period that blood is crossing, and the aortic valve should be actually closed. So I'm expecting that the aortic valve is going to be closed here, and ventricular diastole means that this is being relaxed and blood is coming through the mitral valve. But if the aortic valve is not closed, that means some blood is rushing across it, and that can make noise, as like a whistling effect, as fluid is rushing across that opening. And so that is all consistent with problem with the aortic valve closure, and that's Roman numeral 2. So that's two things that are in favor. One is that we don't see the valve having closed. Two, we see noise occurring during a period that the aortic valve really should be just shut. And so, so that looks like question 3 is Roman numeral 2. And just for interest, we see that Roman numeral 4, we do see the sound of the aortic valve, but we don't see the sound of the pulmonary valve. So Roman numeral 4 would suggest pulmonary regurgitation. Of course, during the real exam, there's no way I would even look at Roman numeral 4, because it was very clear, what the answer was, and you would just answer and move on. But just in retrospect, and also to increase your learning and perception, you can see that. And when you look at Roman numeral 3, we have the correct order of the sounds, which is aortic valve, then the pulmonary valve, as we've been told in the passage. And now we have this suggestion, because it's occurring during systole, contraction of the heart. And so this might be more consistent with an aortic stenosis or pulmonic stenosis. So either one of those. And in fact, ACER could even go so far, if they wanted to have a multiple choice question in which to ask you about systolic ejection murmur. Of course, they would need to define it and then say, look, there's a murmur that occurs during the ejection of blood during systole. So that's contraction of the ventricles. And so they can ask you which of the following, having already been described in Table 1, would be consistent with a systolic ejection murmur. And then you would be able to say that aortic stenosis and pulmonic stenosis would both have that possibility, because that's when you would be having a contraction of the ventricle and then having this sound. And this is more consistent with Roman numeral 3. So even if you didn't like all of that, it's okay, at least as long as you see how Roman numeral 2, the answer was obtained. So next, question number 4. The thin vertical lines during diastole, what does that correspond to? Okay, so now we need to, well, first of all, the vertical lines we've already underlined, hopefully you have, and it talks about the height of the lines, talking about sounds, and it says that normally the aortic valve closes before the pulmonary valve, and the sounds corresponding to the vertical lines are absent or minimal. So these sounds under normal conditions, ACER is saying, are absent or minimal. So question 4, when it's question 4 is saying the degree of ventricular contraction or contraction of the atria, but contraction of ventricles and atria, that's normal. That happens every day. That's happening to you right now. And so, because that's normal, and yet these additional sounds shown by those vertical lines is clearly abnormal, it means that answer choices A and B are impossible. So now we're really trying to find out this abnormality is due to blood going from where to where. Really, that's what we're trying to determine. And so, since it is ventricular diastole, the ventricle is relaxed. Now remember, when the ventricle is contracting, we have closure of the tricuspid valve, closure of the mitral valve, and then blood going through the pulmonary and the aortic valves. So that's during contraction. So during relaxation, now we have blood coming from the atria into the ventricles, and so those valves should be closed. But if those valves were partially open because of some regurgitation that is occurring, that means that we have backflow that's happening across the valve because the valves are not fully closed. And therefore, we have blood that is supposed to be accumulating in the ventricles, and then later when the ventricle contracts, leaving the ventricle into arteries. Instead, we have this moment where the ventricle is relaxing and blood is regurgitating. It's coming back into the heart. So we have blood that's flowing from the pulmonary artery into the right ventricle, from the aorta into the left ventricle. It's flowing backwards and it's making a sound. And this is the sound that's being picked up by the vertical lines. And so the other thing, so this makes it answer choice D, of course. The other thing that I just wanted to underline is sometimes ACER asks a pretty straightforward question, basic question, to get you to look at something and start thinking about something, and then the following questions can be more challenging. So notice that the first question in this unit, which was pretty straightforward if you have basic understanding of the anatomy of the heart and circulation, the first question was trying to make sure that you understood what was happening when the ventricle contracts to the aortic and pulmonary valves. And then after that, most of the focus is on the aortic and pulmonary valves in this particular unit. And so you'll notice that this happens frequently. It's a technique that ACER does, and so it builds on previous knowledge, because I know many of you are used to multiple choice exams where each question is independent of the other and has nothing to do with it, but that's not the way ACER functions. Also, with regards to this, I just have to underline again that the red or the orange GAMSAT practice questions by ACER, you should go through the Unit 1. The first unit in that booklet has a great circulation question and makes that particularly good practice. And if you have the new the book with the 10 practice tests, you're going to find that we have so many questions on circulation. This one, which is also deals with systole in the position of the valves. This is Unit 1 in HEAPS 1. So that's Section 3. And then as well, there's questions to use dimensional analysis and things like that, and stroke volume to calculate that. And later we'll see later in that same exam about the parallel circulation of the body. And finally, I have to give a shout out to MediRed Australia, which also has a couple of exams in this book, and one of their exams, deals with shunts that happen in the heart, and I think that's HEAPS 2 or 4, one of those. HEAPS 2, I think. The second exam in the book. And so, so that's just telling you that circulation is very important. And ACER has a couple of units in this booklet on circulation, and so you should practice it. And in the book, Gold Standard book, it's biology 7.2 and 7.3. I almost forgot to mention why I wrote this. So just to underline what I said before is that biology, the most important things is cellular, knowing some basics about cells. Very basic information. More secondary school level, honestly. But basic information. Then CVT is what we often say for cardiovascular thoracic, which really means circulation for the most part, and also a little chest or respiratory, a little bit about the lungs, but mostly circulation. And genetics, dihybrid crosses, monohybrid crosses, basic information about mitosis and meiosis, and biosynthesis and metabolism. Just a little bit knowing about the ways that, what are precursors, what stimulates, what inhibits, following arrows in a flow chart. So if you do have the book, that's biology chapter 1 for cells and mitosis, chapter 7 for CVT, chapters 14 and 15, genetics, mostly 14. And biosynthesis, metabolism, a little bit biology chapter 4, a little bit, but mostly biology chapter 0. And that is online only, and that's part of the book, but there's over 50 practice questions with graph analysis and flow charts, and that's really what you need for GAMSAT.